In this video, we'll continue discussing evaluating limits algebraically, this time using the method of simplifying fractions. Again, over on the right, I have the different types of strategies that we can use to evaluate limits algebraically. First, direct substitution. In this case, it would mean plugging in x equals 0 into the expression. When we do, we'd get 1/3 minus 1/3, which is 0 over 0. And so we can see that we have 0 over 0, which makes this an indeterminate form. We have to use some other type of method. Factor and cancel doesn't really help here because we don't have anything to factor in the numerator or denominator and therefore nothing to cancel. Rationalizing isn't going to help because we don't have any radicals or radical expressions in our limit. But we do have this complex fraction, and I'm going to rewrite this expression a little bit differently so that the complex fraction is apparent. And I think they just print it horizontally in the numerator because it saves space in a printed book. But we have limit as x approaches 0 of 1 over 3 plus x minus 1 over 3 all over x. And again, the fact that we have a complex fraction here leads me to think of simplifying fractions. The easiest way here for me to simplify this fraction is just to multiply the numerator and denominator by the least common denominator in the numerator. Now that sounds complicated, but we're just going to look at the least common denominator of the numerator, which is 3 times 3 plus x. And we're going to multiply the numerator and denominator by that least common denominator in the numerator. Alright, when we do that, we're going to get limit as x approaches 0 of first of all, we'll have 3 because the 3 plus x cancels with 3 plus x. Then the 3's will cancel and we'll get minus quantity 3 plus x. You have to really watch out for that negative sign or the minus sign and the quantity 3 plus x. And that's going to be all over 3 times x times 3 plus x. Now we simplify the numerator and we get limit as x approaches 0 of 3 minus 3, which zeroes out, over minus x, or 3 minus 3 minus x gives us negative x, and over 3x 3 plus x. Well, here we can see that our x's will cancel, and again, that's what we'd like. Since the x being 0 in the denominator cause that factor to become 0 and the whole denominator to become 0 and undefined. Now when we simplify again, limit as x approaches 0 of negative 1 over 3 times 3 plus x. At this point we're ready to use direct substitution. We plug in x equals 0, we get negative 1 over 3 times 3, or simply negative 1 over 9. And so this is an example of evaluating limits algebraically by using simplifying fractions. And there's at least one other example in this problem set that we could apply this strategy to, number 58. And you can look at it and see that it's fairly similar, and the ideas are easily transferable from this problem to that. All right, we'll stop at this point and go on to another example.